All right, this is section 4.5, transformations of sinusoids. A sinusoid is really just a trig function that we transform. We're going to be focusing on sine and cosine. So let's start with when y equals a times the sine of x or a times the cosine of x. A affects what is called the amplitude. The amplitude is the volume of each wave, and it's always given as a positive number. It's how high and low our function is going to go. Then we have this b value, and b is going to affect the period. B is in with the x. The period is how frequently the wave repeats. So the formula, 2 pi over the absolute value of b, tells the new period. If there's no a value, right, no a listed, implies that we're multiplying by 1. So that means the amplitude is 1. The maxes are 1, the minimums are -1, which should check out with the regular graph. The period, if there's no b value given, then b is 1. 2 pi over 1 is 2 pi. So no b value, the period is 2 pi. You can never say that the amplitude or the period is none. That's not real. The amplitude is initially 1, the period is initially 2 pi, it only changes if there's a value there. And then reflections. If I have a negative sine of x or negative cosine of x, it's reflected over the x-axis. Sine of negative x or cosine of negative x will reflect over the y-axis. So we will state the amplitude, period, and describe how it's related to the graph of y equals sine of x or y equals cosine of x. So this one, we have a number in the front, so that means our amplitude is 4/7. You could just put an a for amplitude, that's fine. P for period, 2 pi over b, well there's no b value, so our period is 2 pi. How is this compared to regular sine? Well, its amplitude is 4/7, which means it's shorter. Its maximums are 4/7, its minimums are -4/7. It's shorter. 2 cosine of x over 3. Well, in this case, our amplitude is that number in the front. Our amplitude is 2. Our period is 2 pi over b. B in this case, remember, I could write 1/3 x. So b is 1/3. To simplify, we multiply by the reciprocal. So our period is 6 pi. So this function has an amplitude of 2 and a period of 6 pi, which means that it is taller than regular cosine, and it's also wider. It's wider because it takes it longer to repeat. So bigger period means wider graph. To graph these functions, you're going to plot some important points on the original function's graph. If the amplitude is a number other than 1, multiply your y-coordinates of each max and min by whatever a is. If the period is something other than 2 pi, divide the x-coordinate of each point by b. And if a is negative, reflect the maximum and minimum values. If b is negative, reflect everything over the y-axis. There are other methods to go about this, though. We're going to talk about one that's a little different. For cosine of x, start by listing all the important features. We've only talked about amplitude and period. The amplitude in this one is 4. The period is 2 pi, and there are no reflections. So if your amplitude is 4, that means your maximum is 4. So I like to draw myself a little dotted line. Your minimum is -4. Your period is 2 pi. I like to mark that out a little bit, 0 to 2 pi. So remember, that's how far it should go to repeat. Cosine usually starts at 1, ends at 1, middle at -1. Well, instead of 1, we're actually going to go up to 4. So we start at 4, we end that one period that I just marked out at 4, and our middle is at -4. And right in between those, we cross our zeros. And now I see my pattern. I go back to 0, -4, 0, 4. As much as I can fit on the graph, because if you only draw one period worth, you will not get full credit. And then connect it in as nice of a cosine curve as you can. Make sure you put the arrows on the ends. Your graphs do not need to be perfect. Mine clearly are not. Mark those important points on the graph and do your best to actually hit them. So for our next one, y equals negative sine of 2x. Well, this one, the amplitude, there's nothing there, so that means our amplitude is just 1. Our maxes are 1, our minimums are negative 1. So maybe I'll draw that in quick. Maximums, minimums. Our period is 2 pi over b, which is 2, which means our period is pi. So from 0 to pi, I'm going to get a full period in. And then there's also this negative out front, which is a reflection over the x-axis. Normally, sine starts at 0, ends at 0, middle at 0, and it goes up, down, back up. If we're reflecting over the x-axis, instead of going up, we're going to go down, up, back down. But it starts at 0. This one period ends at 0. The middle is still at 0. And in between the zeros, I'll go down because I reflected, then up. And then I follow my pattern. And on the left side as well. Make those important points. And then connect them with as good of a... Ooh, what did I do? Oops. Screwed that one up. There we go. All right, ignore that little mess up there. And there's our graph. The smaller the period, the more repetitions of it you'll be able to fit. Negative 4 cosine of 2/3 x. Let's start with our amplitude. Our amplitude here is 4. Our period is 2 pi over 2/3, which is 2 pi times 3 over 2, which is 3 pi. That's a fun period. And we have a reflection over the x-axis. Now, another way to go about this would be start by plotting important points from just regular cosine. All right, so I go 1, 0, negative 1, 0, 1, 0, negative 1, 0, 0, negative 1. And same thing on the left. There we go. All right, so my original is orange. And I like to make myself a little key. And I switch colors. Now I would change my amplitude. Well, my amplitude is 4, so that means any max is now at positive 4. So any of these jump up to 4. And any minimum goes down to negative 4. My zeros stay where they were. If I wanted to, I could connect these, right? Just do a light. Ooh. It's not my final answer, so it doesn't have to look great. Whoops. Missing things. There we go. There's the amplitude. Then we'll deal with our period. The period is 3 pi. So I take every single x coordinate and divide it by b. Dividing everything by 2/3. Well, 0 divided by 2/3 is still 0. Pi over 2 divided by 2/3 is 3 pi over 4. Pi divided by 2/3 is 3 pi over 2. So this point goes over here. 3 pi over 2 divided by 2/3, 9 pi over 4, which is right here. 2 pi divided by 2/3 is 3 pi. And now I can kind of see my pattern. I'm going to go 1, 2, 3 lines. 3 lines. All right. There we go. And on this side. Okay, the green is my period change. Period changes are the trickiest ones. And then finally, label this period. Finally, we need the reflection. We are going to reflect over the x-axis. So I take every point that's on the x-axis and it stays. That one. See, this one starts to get all sorts of crazy here. And then I take any minimum, reflect it up to a maximum, any maximum, reflect it down to a minimum. And then draw my best version of the final graph, trying to keep my colors straight about which color is my final answer. If you do this method, please make sure to either highlight your final graph or color code it and tell me the red is the final, something like that. You can see that this one gets very, very messy. It's an option. Choose the way you like to graph it. All right, 1/2 cosine of negative x. This one has an amplitude of 1/2. It has a period of 2 pi because there's no b value besides the negative. And that negative is a reflection over the y-axis. So my maxes are 1/2, which is just the one mark here. Minimums are -1/2. My period doesn't change at all, right? 0 to 2 pi, but I reflect over the y-axis. So instead of drawing my function normal, I'm going to go 0 to -2 pi. Cosine starts up at 1, so 1/2. It ends at its maximum again, the middle's at its minimum, and we cross in between. Notice that a reflection of cosine over the y-axis does nothing. The graph looks exactly the same as it would have without the reflection. Cosine is special like that. Sine does look different. But there's our graph.